Today we have a Telefunken Opus Studio 5650MX. And here are the guts of this device. It is an interesting combination of early semiconductors such as these, or over here, transistors, and glorious Telefunken vacuum tubes, which are sitting in various places here, including a tuning eye tube. And so as a result you have a combination of high voltage capacitors, that's a 50-50-50 microfarad by 350 volts, and low voltage capacitors, such as these here. Well, actually those are the new ones. The old ones are back here, can't even access them, which are something like 35 volts. Furthermore, these transistors are ultra rare, ultra expensive, and extremely fragile, and I've heard just powering this unit on, if something's wrong they can blow out. And I don't know if they work or not, because this is, well, it wasn't working when I got it, and I'm hoping I can get it to work. So I started to recap it. I've already taken out the bypass capacitors here for the gain stages, which are the transistors, and those were relatively straightforward. I started working on this one, obviously. I've got to get the high voltage cap bypassed here, and another monstrous cap somewhere back here. Alright, I'm not sure I can see it. There he is, way back there. That's a big one. Bypassed. This is the amplifier stage here. So if you take a close look, you see there's a power transformer back here, but there is no output transformer. And that's because the radio stage is all tube, preamps and everything, and the power stage is this sort of hybrid, or this sort of solid state device stage here. So this is what we're up against today, trying to repair. And I'm just going to keep trying to recap it, because that's the first thing to do. There are a lot of capacitors on this board that need to be recapped, I'm sure. Whole bunch of electrolytic caps. Probably most of them are bad, and I'd rather replace them now than burn something out and need to replace those later. Here we go. I've got some capacitors here. I'm not sure how old they are, and I want to check to see if they are reading the right capacitance or not. Well, my capacitance meter can't read 100 microfarad caps, so I'd have to hack something together here to do a quick test and see if it's in the right realm of possibility here. So this is the capacitor equation here, and for a time of about 0.35 seconds, if I discharge the cap with a 1K resistor, I'll get about 100 microfarads. About a third of a second, which is 100 microfarads. They're definitely good. It was the first two I tried, so looks like probably most of the batch might be fine. Wow, that took me hours, but I think I got them all replaced here. All these caps are new now. Getting rid of the old dried out ones. When you see a cap that looks something like this, with the stopper, the rubber stopper in the middle there is just cracked, split, it's kind of popping out of the case, you know that cap is no good. And so definitely it's a lot of work, but these caps need to be replaced. Hopefully they'll last another 50 years or so. But that's only that board. I still haven't done this board. I still haven't done this board. Still haven't done the power supply cap here, the power supply cap here. So there's a bunch more caps to go, and I'll probably find even more as I continue to look. There we go. That was the last capacitor for that board. So now I've got two boards done, and I guess one more to go over here with the radio stages. Whew, that was a lot of work. Hope it works when it's done. And here's the lovely trash bucket. That was a lot of capacitors to remove and replace there. Wow, all done though. Well, so far it's been about 8 hours worth of work, but I think I got all the capacitors replaced in here that could be bad, which are the electrolytic capacitors. Now, I was really hoping that when I plugged it in and turned it on that it was going to work, but it didn't. The transformer here smelled really bad after about 10 minutes, like burning tar or something. It was horrible. So I said, well, I guess this transformer is probably shot, therefore the whole project is a waste. So I disconnected the power here, and I disconnected the power on right here, and I started measuring the voltages on this output transformer to see if I could replace it. Then I discovered that these blue wires here measured almost 0 volts, and those go all the way to the amplifier over here. And when I measured this side, it was 0 volts. And I said, well, that's odd. It seems like I'm shorting the transformer out. So I disconnected the wires here, and lo and behold, it went up to 48 volts. So it looks like that there is a bridge rectifier in here, solid state of course, which is burned out, and it's very, very easy to replace, very cheap. And so there's hope still that once I replace that, maybe this whole thing will work. We'll see. Yes, I do have a ridiculously tiny speaker hooked up here for testing the amp out. But actually it showed that part of this amplifier does work. When I touch these terminals here, I do indeed get a little pop sound, which is where the signal comes into the amp. So I believe this amplifier is actually working a little bit. The question is why this part's not, and so this block here is a bridge rectifier, a very old bridge rectifier. So this is the part that needs to be swapped out now, and hopefully it'll fix everything. I did spray contact cleaner in all these pots here and the loudness control, and I did a variety of other cleaning operations in here because there's a lot that needed to be cleaned. A lot of cat hair, a lot of dust. Probably need to go over the entire thing again with a bunch of Q-tips and isopropanol and try to get it nice and cleaned up. Yes, indeed, this little bridge rectifier is totally fried. It's a sort of oddity because it's got the AC terminals both on the same side, and then the plus in the front and then minus on the back there. So with that in mind, this should be some positive voltage because it's a diode, and it's 0, dead short. If I go from the AC to the negative side, however, which I have to put the black one on there to get the negative voltage, I get a reasonable voltage for a germanium semiconductor of about 0.37 volts. And if I go from this other AC input to that same negative side, again, nice germanium voltage there. However, if I go to the positive from the other AC, a dead short. So we've got 2 dead shorts in here, 2 completely blown out diodes. So let's replace that. Okay, we got that little rectifier in place there, and I found another short, just 2 wires that shouldn't have been touching, and so we turn it on, and we're getting signal out of that little speaker. This is the AM. You can tune it. It's off to a good start here. There's also shortwave bands and FM, except the FM antenna is not hooked up right now, so probably won't get anything on FM here. Oh, we got a little bit. Well, there we go. We even got a little bit of FM without the antenna plugged in. All right. treble's working. Of course, there's only one speaker, so there's no balance. The tuning eye tube is alive. Probably need to hook the antenna up to see if I can get it to close there. Beautiful. Alright, we're on to something here. So that is one channel. Let's see if the other channel's alive. Hey, hey, hey! Alright, we got two channels at work. This is awesome. Wow. A lot more things to test. The real player input, the record player input. Gotta try some of these other bands out, shortwave and whatnot. Replace a couple bulbs, a lot more cleaning to do. But this thing is looking like it is alive. And I am not smelling that horrifying stink that I smelled yesterday. So I think we are doing good here. Looks like all the tubes are working. I already put contact cleaner in all these switches, and I exercised those, and they seem to be working pretty well. So here we go. Good stuff.